Good day everyone. Welcome to my channel. The other time we discussed regression of y on x, but this time around we'll be discussing regression of x and on y. And in this example we'll be using three different methods to solve this problem. Now let's look at this. The question says fit a least square line of x on y to the data below, and this is the data. So now we are looking for the coefficient of regression in this of this model. Now we have a column that satisfies the x and we have the y column. Now we want to fit a regression of x on y using this data. Now like I said, we're going to use three different methods, but first of all, let's write out a regression model of x and y. Now we said x equals to alpha plus beta y. This is the regression model of x and y. Now the first method we'll be using, say the method 1. Method 1, we'll be using the formula for calculating the coefficient of this regression. The coefficient here is alpha and beta. Now the beta is given us, we have beta equals to n summation xy minus summation x summation y divided by n summation y square minus summation y all square. Now in this formula for getting the beta, which is the slope of this model, now we need summation x y. Now from this table, now we're going to form a column that is going to satisfy summation x y. Now let's draw this. We have this to form another column. We say this is x y, and what xy represent means the multiplication of this column and this column. Now we have this, says our xy will give us 3 times 2 6, 5 times 3 15, 6 times 4 that will give us 24. This times this number that will give us 48. 9 times 5 that is 45. Now we have 11 times 8 that is 88. Now here we have summation x, summation y. Summation x is the addition of all this column, so summation x here will give us 42. If you add all this column together, we're going to get 42. Now summation y, adding all this column together, our summation y will be equals to 28. That is our summation y. Our summation y is 28. Now we need summation xy, and the summation xy, say summation xy will be equals to summation xy 6 plus 15 plus 24 plus 48 plus 45 plus 88, and that is going to give us 226. So in short, here we have summation x to be equals to 42, summation y to be equals to 28. Now we have summation xy equals to 226. Now using this same formula, we need summation y square, which means we need another column to form y square. Now let's form the y square. Now it means we are going to square each number in this column, and such we're going to have 2 squared that will give us 4, 3 squared that will give us 9, 4 squared that will give us 16, 36, 25, and 64. If you add all this column together, and that is summation y square, summation y squared. If you add up all this column together, this plus this plus this plus this to this, so we're going to get 154. We have 154. Now with this, we're able to go. Now we substitute all this value into this formula. Therefore, we have beta equals to an n. And n is the number of observation here. We have 1, 2, 3, 4, 5, 6. We have 6 rows. It means our n is equals to 6. Therefore, here now we're going to have an n that is a 6 multiplied by summation xy, and our summation xy is 226. 226. Let's close bracket minus summation x. Summation x is a 42. And summation y is 28. So we close the bracket. So everything divided by our n still remains 6 multiplied by summation y squared. Summation y squared is 154. 154 minus summation y, everything squared, and our summation y here is 28. Therefore we have 28 raised to power 2. Now if we open this bracket and this, we're going to have beta equals to 6 times 226, and that will give us 1356 minus 42 multiplied by 28, and that will give us 1178. Then divided by 6 times 154. 6 times 154 will give us 924. 924. So minus 28 raised to power 2. 20 raised to power 2 will give us 784. Therefore, we have beta equals to 1356 minus 1176 will give us 180 divided by, so we have 924 minus 784, and that will give us 140. Therefore, our beta equals to 180 divided by 140. That will give us one whole number 2857. Therefore, our beta equals to 1.2857. So that is the slope of this model. Now we need a constant, which is the alpha. Now we're going to use two different methods to find our constant alpha. Now the first method is this. You have alpha equals to, let's look at the formula. In the formula we have summation x, summation y is equal to minus summation y, then summation xy, all divided by n summation y squared minus summation y all squared. You can see that both the denominator and the alpha and beta are the same. The only difference is just this numerator. Now we say in this numerator we are in summation x, we already have our summation x. Summation y squared, we already have summation y squared. Now we are in the summation y, we have our summation y, then summation x y, and we already have our summation xy. So therefore now let's apply the formula and see what we got. Now I said alpha equals to summation x. Our summation x is 42 times summation y squared, and our summation y squared right from here is 154. 154 into bracket minus summation y. Our summation y is 28 times summation xy, and our summation xy is 226. 226. So divided by n summation y squared minus summation y squared, just exactly as we have here. So here we have 6 times 154 minus 28 raised to power 2. Now we have alpha equals to 42 multiplied by 154. That will give us 6,468 minus 28 multiplied by 220. That will give us 6,320 8, then we have divided by, like we already have it here, say 924 minus 784, and therefore our alpha will be equals to, say alpha equals to 6468 minus this, that will give us 140, divided by 924 minus 784, that will give us 140. Therefore we have our alpha to be equals to 1. Our alpha, since we have this, we say alpha equals to 1. Our alpha equals to 1. Now there is another shorter way of getting this alpha. Alternative way of getting alpha. We say alpha equals to x beta minus the slope, which is beta, x bar minus beta y bar. Our x bar is the mean of x, so we have x bar equals to summation x divided by n, and this will definitely give us summation x right from here is 42, so we say 42 divided by 6. Therefore our x bar will be equals to 7. Now y bar, y bar is the mean of y, so we have summation y divided by n, and this is equals to our summation y right from here is 28, so we have 28 divided by 6. Therefore our y bar will be equals to 4.6667. Now substitute this into this formula. Now we have the alpha equals to x bar, and our x bar is 7 minus our beta. The value of our beta here is 1.2857, so therefore here we have into bracket 1.2857 multiplied by y bar, and our y bar is 4.667667. Now here we have alpha equals to 7 minus multiplying this by this, that is 1.2857 multiplied by 4.667, and that will give us 5.9997. Therefore alpha equals to, approximately this to one decimal point, or subtracting this from this, we can usually have 1.00002, and approximating it, we're going to have 1. You can see right here we have alpha to be 1, and at the same time we got alpha to be 1 here. Now our beta, which is the slope, is remain the same, which is 1,208.57. Now substitute all those the value of the coefficient back into this model, then we're going to have x equals to alpha, which is 1 plus, and our beta is 1.2857. then we have y. So this is the regression model of x and y on this example. Now this is our first method of solving that. Now we're going to look at another method of solving it and see if actually we're going to have something similar to what we've already solved, and that is exactly what we're going to do now. So we're still on this the same question, which we should fix regression model on x and y. We want to compare using another method. Now this, if not forget, we have x equals to alpha plus beta y. That is our model. Now we want to use another method, then we call this one method 2, second method of solving simple linear regression of x and y. Now what are we going to do here? Now this is very simple. Now we have this, we said b or rather we're talking about beta, say beta equals to, just split it out, beta equals to summation xy, beta equals to summation xy. Now here you can see we have capital and we have capital S and capital Y, but in this case we are dealing with lowercase, small letter x, so summation xy divided by summation y squared, in which our x will be equals to x minus x bar and our small y will be equals to y minus y bar. So that is exactly what we need to form in this column now in order to get exactly what we are trying to find out. Now we need another column here, since and this column is for x and y, saying small x equals to capital X minus x bar, capital X minus x bar. So since we have x minus x bar, we need to find the value of x. So we say x bar, just like what we did the other time, so x bar equals to summation x over n, and this will be equals to our summation x right from what we solved the other time. Here we have summation x, so summation x equals to 42, summation y equals to 28. Now our summation x right will just be 42 divided by 7, and 42 divided by, rather, our n equals to 6, so 42 divided by 6, rather, our n will be equals to 1, our x bar equals to 1. Now since our x bar equals to 1, we are now going to subtract each value of this column x here from this one, which is the mean of x, and say what we're going to to have. Now we say, how do we do that now? So okay, so here we have 3. And the other way around, we have another value here. Now since this is our alpha, x equals to alpha plus beta x y. Now we've gotten our x bar to be 7. Our x bar to be 7. 42 divided by 6 will give us 7. So that is what we're going to subtract from here. So 3 minus 7 will give us minus 4. 5 minus 7 will give us minus 2. 6 minus 7 will give us minus 1. 8 minus 7 will give us 1. 9 minus 7 will give us 2. 11 minus 7 will give us 4. Now our x, saying this is capital X. Now our summation small letter x will give us, if you add all these up, say minus 4, minus 2, minus this, minus this. Now we're going to have what we have. Say minus 4 we cancel this minus 4, minus 2 we cancel this minus 2, minus 1 we cancel minus 1, and at the end you can see this is going to be 0. But this is not our point of interest, because in this formula we have to multiply this x by y. So we need another column for y, and this will be so small y equals to capital Y minus capital Y bar. So therefore we also need y bar in this case. So alright, so y bar equals to summation y over n, and that will be as our summation y, which is 28, divided by 6, and like we also the other thing, our answer is 4.66667. But this time we are going to approximate it to 2 decimal points, so that will give us 4.67. That is our y bar. Our y bar is 4.67. Now we're going to subtract each value of y here from this 4.67, and let's see what we're going to have. So 2 minus 4.67, that will give us minus 2.67. 3 minus 4.67, and that will give us minus 1.67. This minus 4.67, and that will give us minus 0.67. Now we're on 6 now. 6 minus 4.67, that will give us 1.33. 5 minus 4.67, that will give us 0.33. Then the last one, 8 minus 4.67, and that will give us 3.33. Now we've gotten the small value of y. Now, and this formula says we should multiply x and y. Now we need another column that will multiply these together. Let's form a column here. So alright, here we have a small letter x multiplied by a small letter y, and that is exactly what we need from this formula. So okay, now we'll say, since we already have that, say this column multiplied by this column, minus 4 multiplied by minus 2.67. This column multiplied by this column, that's how we're going to do that. Minus 4 minus 2.67, and that will give us 10.6668. Another say 10.67. Now this multiplied by this, we have 3.34. This multiplied by this, that will give us 0.67. This column multiplied by this column, that will give us 1.33. This column multiplied by this column, which is 2 multiplied by 0.33, and that will give us 0.67. If we approximate it, we have 0.67. Now the last one, which is 4 multiplied by 3.33, and that will give us 13.2. So 13.32. Now in this case, now we need a summation xy. We need summation xy, that is adding all this column together. If you add all this together, our summation xy will give us 30. So we have 30 here. So 10.67 plus 3.34 plus 0.67, we're going to have 30. So we already satisfied the summation xy. Now we need y square, which means this small y here, we need to square the value and see what we're going to have here. And that is our last column here. So y square. So each value here, we're going to square it and see, and let's see what we have, what we gather. So here now we have minus 2.67, and that will give us minus 2.67. That will give us 7 points. We have a 7.12. 7.13, so 7.13. This raised to power 2 will give us 2.78. This raised to power 2 will give us 0.45. I think 0.45, if not 0.44. So 0.44. this raised to the power 2, that is 1.33 raised to the power 2, and that will give us 1.7, say 1.77. This raised to the power 2 will give us 0.11, so 0.11, and 3.33 raised to the power 2, and that will give us 11.01, if not 0.10. Now we need the summation y square. So summation y square, if you add all this together, this is going to give us 2.23. This is going to give us 23.3, if not 23.34. Alright, so now we've already gotten this. Now what remains here is now apply this formula, which says beta equals to our summation xy now is 30. So we have 30 divided by summation y square, and summation y square is 23.33. Now we'll divide this by this and see what we get. What we got? So beta now equals to 30 divided by 23.33. That will give us I think to be 1.28. If not 1.2, yes, 1.28. Now since we're getting beta to be 1.28, although from the calculator this is an approximation, from the calculator we have beta to be equals to 1.2857. Now this is the coefficient, this is the approximate of this. Now this is the coefficient of this beta. The value is still 1.2857. Now we need to get the other model, which is the alpha. And how do we get our alpha here? Now we are not going to use a separate formula of getting alpha, rather we are going to use a formula in order to get the whole thing. I will say x minus x bar equals to beta into brackets y minus y bar. Now in this case we are talking about the capital Y and not the small letter x and the small letter y here. Now we're talking about the capital letter X and the capital letter Y. Now we have x minus x bar. Our x bar from here is 7, so we have 7 equals to beta, and our beta from here is 1.2857 into bracket we have y minus y bar, and our y, so y minus our y bar is remain 4.67, so 4.667. Now if we multiply this like that, we're going to have x minus 7 equals to 1.2857y, that is this multiplied by this minus this multiplied by this will give us 5.99976. Therefore our x will be equals to say x bar s will be equals to 1.2857, so 1.2857y minus 5.99976. By the time we move this to the side, we have plus 7, and therefore we're going to have x equals to 1.2857y. By the time we will do this together now, we're going to have plus, and when we have plus, what are we going to have? So this multiplied by this, we subtract from this, we're going to have maybe 1.000 so by the time we now approximate this, we're still going to have an x bar, so x equals to approximate this, which is 1.000 approximate to be 1, so we have 1 plus 1.2857y, which means therefore our alpha right from this model will be equals to 1. Our alpha is 1, whereby our beta is this, and our model is x equals to 1 plus 1.2857y. So this is the third method. Looking at this method here, we're using method of matrix. We're using matrix method to solve the coefficient of regression of x and y. Now in this matrix method, what we need, we have our model to be x equals to alpha plus beta y. Now multiplying this model by summation will give us the first equation here, which is a summation x. We cannot have summation alpha here because our alpha is not variable, it's coefficient, but let's say it's constant. That's why we have n multiplied by alpha plus beta summation y, because we already have y here. Now we already formed equation 1 with that. We need equation 2, and how do we do the equation 2? We multiply this model by summation y. If you do that, so summation y multiplied by x will give us summation xy, summation y multiplied by alpha summation y, and here we have alpha summation y squared, because that is summation y multiplied by y, so we have summation y squared. Now in this model in these two equations, we need summation x. We've gotten summation x here to be 42, which is here 42. We need n. Our n is the number of observation, which is 6. Now we need summation y. Our summation is addition of all this column, and that gives us 28. Adding all this column will give us 28. Now we have summation xy. Summation xy is multiplication of these two columns. Each value in this column will multiply together to get this summation xy, and that's why we have 3 times 2, we have 6, 5 times 3, we have 15, 6 times 4, we have 24, we have 88, 11 times 8, 88, and adding all this together will give us summation xy, which is 226. Now finally we need a y square. We need summation y. We've gotten summation y here. Then we need y square. Then we'll form another column to form our y square. Now summation y square will give us the whole this, and that will have 154. Now substitute all the summation into this equation here. It will give us 6 alpha. We say n is 6 alpha plus b summation y. Summation y is 28. We have 28 beta equals to summation x here, which is 42. That is 42. Summation y 28. So here we have 28 alpha plus summation y square 154 beta. That's all we have, 154 beta here equals to what? Summation xy. And our summation xy here is 226, and that's why we have 226 here. Now representing this in a matrix form leads to this, that is 6 28 equals to what? 42. We have 42. We are taking the coefficient. 28 154 equals to 226. 28 154 equals to 226. Now the general determinant of this alpha and beta is what we have here, and you remember how we got our determinant. So this multiplied by this minus this multiplied by this, and that's why we have 154 multiplied by 6, 154 multiplied by 6 minus 28 multiplied by 28, and that gives us 924 minus this. Subtracting this from this will give us 140. That is the general determinant. Now then, for us to get the alpha, we need to get the determinant for this alpha separately and later divided by the general determinant. So here we are not going to replace these equal values in place of alpha here. So instead of having 628, we're having 42,226. You can see 42,226 already replaced the column of this alpha. Now we put the other one of beta until we have 28 154. Why is this? Because we are looking for the determinant of alpha here. So the determinant here will give us 42 times 154. We have it here minus this times this 2226 multiplied by 28. We have it here. If you multiply this, we are going to have 6468 minus 226 multiplied by 28 will give us this. If you subtract this from this, definitely we are going to have 140. Now we need the determinant of beta 2. So this column here is going to we're going to replace this column by this equal values here. So instead of having 28154, we're going to have 42226 in the second column, and that is what we have here, 42226. Then the value of alpha will come back. Is what we return it. It is a 628. Then the equal values, which is 5226, and we look for the determinant here. And looking for the determinant here lead us to this. We have 6 multiplied by 226. That's what we have here, minus this times this. Is just like cross multiplication, then subtraction. Now we have 42 times 28. We have this. Now this multiplied by this will give us 1356 minus 42 times 28 will lead us to this. Subtracting this from this give us 118. Now we need to get the value of our alpha. Our alpha is the determinant of alpha minus our general determinant. The determinant of alpha give us 140. Determinant alpha 140. That's 140 here. The general determinant here lead us to 140. So divide this by this will give us 1. Now we need to get the quotient of to get the quotient of beta or the slope. So determinant of beta minus general determinant. Determinant of beta here give us, we have beta, which is 180. So we have 180 here. So determinant of beta equals 180. That's what we have here. Divided by the general determinant, which is 140. Divide this by this will give us 1.2857. Now substitute this 1 and 1.2857 into this model. Therefore we have x equals to 1 plus 1.2857. So that is our model, which is not different from the method we did the other time. We see have 1.12857y, and the method we try, we still have 1.12857y. So that is the 3 method of getting the regression, the simple linear regression. But in this case, we use simple linear regression of x and y. Thank you for watching.